everybody. My name is Xinjie Tan, and I'm one of the team lead for the e-thermal sensor project.
And DQ, I'm the other leader.
So our project is hosted by Professor Wang, and our goal is to research on how the size of K-type thermocouple affect its time response. And so for the previous year's group, they were also trying to reduce the time response for the K-type thermocouple. If we reduce the time response, we will also increase the efficiency of the whole system. The whole system is measuring the time difference by the Arduino system. So the previous year, they tried to add a carbon coating on the tip of the thermocouple to let the thermocouple reduce the heat more quickly than usual to then reduce the time response. And sadly, they didn't actually do the process last year. So this year we talked with Professor Wang, and he told us to focus on the size of the thermocouple and see how does that change the time response. So for this quarter school, we try to focus on the setting up the Arduino system of our thermocouple. And for next quarter, we will focus on actually testing the size of the thermocouple and the time response for that. Sorry. So our main this one. So the requirements, like why we use the K-type thermocouple, because as you can see, the K-type thermocouple has the most linear relationship between the voltage difference and the temperature difference. So how does the thermocouple works is that it measures the voltage difference. When the tip of the thermocouple get into different temperatures, it will create a voltage difference because of the EMF effect. Then we can measure the voltage difference. Then we can calculate the temperature difference by using this graph. And the coefficient, the linear relationship between voltage difference and the temperature difference, we call it like the C-big coefficient.
And we don't use J-type and E-type because they're too expensive. We're probably gonna use the J-type next quarter when we expand our budget.
Yeah. Our team goal for the whole year is to reduce the time difference from 0.06 seconds to 0.03 seconds by reducing the size. It's our assumption that by reducing the size of the thermocouple, we will get a lower time difference. And yeah. And our organization and subsystem breakdown is our advisor is Professor Wang. And as a team leader, me and Chicho, we focus on design and doing the experiments, and then communicate with Professor Wang, and then assign the different works to our teammate. The Zijian, Zhang, and Bowen Chen, they are focusing on the researching and designing the schematics. So basically, it's circuits for our Arduino system, which include the thermocouple, and right now include the amplifier, and will include the Bluetooth device in the future. The Zhengtao Li and Sun Kun Li, they are searching the Arduino code, and they work together with this team, and they also debugging and compute the Arduino code with the schematics. And then after we do the experiments, they also analyze the data that we got. The timeline for our project is like this is a simplified timeline. And for the full quarter, we mainly focus on the design and finishing the whole system and calibrate the thermocouple system as well. And then at the last week of the full quarter, we will add the Bluetooth component in our system. Since like previous year, they also had the Bluetooth component in their system, so we already got the data for that. So that should be pretty quick for. So that's why we put it at the week 10 for this quarter. And for the winter quarter, we will actually test the relationship between the size of the thermocouple and the time response for that. After we finish that, we'll just talk about analyzing the data and then contribute the paperwork. For the object.
So for the fall quarter, our objective is first to calibrate and using and add our amino system and coding into our to get our data for time response and the corresponding voltage change. And for the winter quarter, the new members will add in our team, and they will basically focus on how to reduce the size of the thermocouple, because the thermocouple basically have a tip on the end of the thermometer, and that's like a very small tip. And the professor required that we should reduce the size in micro scale, which is like in millimeter. No, because by size it will be counted in area and volume. It will be come to the 10 to the -6 degree, and then by the spring quarter we will probably compare all the results from our data by see how does the changing in size will affect the time response of the thermocouple. And these are the pictures when we took during our experiment. This is the boiling water, this is the ice water, and we put our thermocouple tip into different temperature of the water, and we have like two end of the thermocouple and one end into the, for example, ice water, and the other set it into the room temperature. And therefore, because of the EMF effect, it will produce a voltage difference, which we can see by we can calculate different size of data and see what's the feedback coefficient, and then we calculate the temperature. We deduce the temperature difference, and this is our electric schematics, which we connected to the Arduino system, and then we are ordering an amplifier to see how does the voltage change, because the Arduino system only can receive a very rough scale of the voltage. They can be very accurate data, and then we need an amplifier to make the voltage change bigger so the Arduino can sense it. And so for the experiment, we first put our testing thermocouples to the ice water and boiling water to calibrate it, and then we connect it to the Arduino system and run the code. And then when the temperature is, the voltage change is stable, we remove the thermocouple from the ice water or boiling water, and then we do multiple rounds of the experiment and then collect data, and then we sketch the temperature versus the time response, and then we analyze the data to calculate the feedback coefficient. So this is our budget. With the budget we handing for the Europe is around $300, and we already purchased all of the equipment that we need. So basically we just need several thermocouples, which is not expensive, and then we add amplifier this week, which already arrived yesterday, and so our total budget for now is around $250, so which is really cheap. And this is our 6 members, and most of the members are enrolled in 3 units, and we work in average 9 hours per week for the project.